This video will cover everything that we did in class today on April 22nd or on April 20th if you're in my 5th period. So the first thing we talked about was a do now exercise that I projected on the screen where we worked with a hanger diagram that looked like this. And you should be taking notes in your notebook to follow along. It'll be helpful to have this tape diagram, or this hanger diagram rather, down in your notebook just so that you're clear on exactly where we are getting everything in this equation. So you should end up with 3 boxes of x on the left side and that rectangle of 11 on the right side. I'm trying to be nice and neat here. So we know that the middle of our hanger diagram represents our equal sign. And of course, the right side of the equation is simply equal to 11. We see that 11 there, all by itself. Now on the left side of the equation, we have 3 x's. And recall that when we're working with hanger diagrams, we always want to default to addition. So in other words, I'm adding x plus another x. X plus x plus x is equal to 11. Now, while we always want to start with addition, this question is a little bit unique because I can see that I have 3 groups of x. And when I have 3 groups of x, I can also simply write my equation as 3x. 3x equals 11. Now remember that 3x is the same thing as saying 3 times x. When we're working with variables, letters to represent numbers, we don't need to write the multiplication symbol. We can simply hug the letter and the number together. Today's learning target is for students to be able to find the solution to equations involving decimals and fractions. And this do now is actually a great example. The solution to the equation is what x has to be equal to for the equation to be true. In the example of the do now, we know that 3x equals 11. Now, you might remember from earlier on, a few lessons before we finished the ratios unit, we talked about how if you are multiplying some number a times another number b, which equals another number c, we can also divide our products by either a to give us b, or we could also divide our products by our other factor, b, to give us a. And that same logic applies here, even though we're working with a variable. So I know that I have 3 times x equals 11. So think of it this way. If I know that 3 times x is equal to 11, I also know that 11 divided by either 3 or x is going to equal the other product. So in this case, if I do 11 divided by 3, I know that it will be equal to x, our unknown number. And so I can simply divide 11 by 3, and 11 divided by 3 is equal to 3.66. And it's always helpful to check your work. What is 3.66 times 3? Well, that equals 11. So I know that I have the correct value for x here, 3.33, 3.33. And so I can come back up to my solution. And I know that x is equal to 3.33. So in summary, when you are asked to find the solution to an equation, or you might also be asked to solve the equation, and being asked to solve the equation simply means to find the solution. To solve the equation is the same thing as finding the solution. You are trying to figure out what x is equal to make the equation true. And that's what we practiced during class today. If you're making up for missing class, at this point in the notes, I would suggest that you pause the video and try Desmos slide 7 and 8. Okay, so if you're making up class, hopefully by now you've gone back and you've watched Desmos slides 7 and 8. One trick to check your work is that question 1 on slide 7 should have the same answer as question 1 on slide 8. Question 2 on slide 7 should have the same answer as question 2 on slide 8, and so on. The question that I really want to focus in on is question 3, and we're going to talk about question 3 on slide 7 and slide 8. So let's start with slide 7. Question 3 on slide 7 looks like this. It is 21 equals 1/4 x. And of course, we know that what this means is 21 equals 1/4 times x. There are a lot of different ways that you can approach this problem. One of which is this strategy we learned above, or we reviewed above, I should say, where we can write a division sentence to help us find the missing number in our multiplication sentence. So let's think about it. If I know that 21 is equal to 1/4 times x, I also know that 21 divided by 1/4 is equal to x. Because again, I'm taking my product, 21, dividing it by one of the factors I know, and that will be equal to my missing number. We want to think back to Mr. Howard's class, KFC, keep, flip, change. We're going to keep 21 the same. We'll flip our division symbol to a multiplication symbol, and we'll change 1/4 to 4/1. We simply end up with 21 times 4, which is equal to 84. That means that x equals 84, right? Because x was this number here. Now, it's always helpful for us to check our work. We can go back to the original problem, 21 equals 1/4 times 84, and you can check to make sure that's correct. 21 equals 1/4 times 84/1. We'll multiply top times top and bottom times bottom. 84/4 does in fact equal 21. So we know that the correct value of x is 84. Now, another way to think about this question is that 21 equals 1/4 x is the same as saying 1/4 of some number is 21. And so we could draw that out as a picture, right? If we think about some mystery number representing the whole diagram, and we know that 1/4 of that diagram is 21, we end up with 4 pieces, 21, 21, 21, and 21, for a total of 84. That's another way we could think about this question. So if you were stuck on this in slide 8, I encourage you to go back and give slide 8 a try before I show you exactly how to do it. On slide 8, the question looked like this. We had 28 equals 1/3 x, and we could follow exactly the same system, the same procedure that we did for slide 7. 21 is 1/4 x. So again, I know that I can divide my product, 28 divided by 1/3, to tell me my missing factor. I'm going to follow that same keep, change, flip procedure, and I end up with 28 times 3/1, which equals 84. And I can always check my work by taking 84. Again, x equals 84, and plugging it back into my original equation, right? If x is 84, 1/3 times 84 does in fact equal 28, but it's always helpful to check our work. 28 does equal 1/3 times 84. And I'm going to use a dot to represent multiplication. It makes it a little bit more clear since we were working with the variable of x. And that's how we find the missing value in an equation involving fractions. So at this point in class, our next step was to head to activity 3 in Desmos. So I'll write those directions on the screen. Go to activity 3 in Desmos. And I want you to take a look at those independently. A few reminders before you get started. When you're on activity 3 in Desmos, make sure you underline the problem. Don't forget to draw a picture. It explicitly asks you to draw a picture. And then also know that there are multiple answers. Once you finish with slide 3, make sure that you give a look at today's exit ticket. And as always, if you need help, I will see you in office hours.